How is everybody doing today? I'm doing well. I hope you are as well. My music is screwing up all over the place, so just give me a second here while I don't know what's going on with my Bluetooth speakers, but it's either a Windows issue or a Bluetooth issue, and I just haven't been able to figure it out, where sometimes the music will just cut out, but if I switch to headphones, it's fine. They're only like 2 arms lengths away from me. It only seems to happen sometimes. It's not consistent. A lot of the time it just works fine. And then sometimes it just says nah. So there we go. We got the in-ear monitors in now. I do have to keep somewhat of an eye on the time. I have a phone call that I have to take in a little over an hour. But so we have made progress. I did a little bit of work offline on this. Now we can probably still make this cleaner. We can probably still make this nicer, but this is where we're going to say good enough and move on. We're going to continue. So, we got ourselves our big buffer. I don't believe we need this anymore. We're doing a check for end of... Oh yeah, we do that check for end of file now. Exact. So this isn't needed. So if we find the start of the game, if we already found it, look for the end of the game. Otherwise, take a quick peek down here. Are we on an open tag? If so, we found the start of the game. If we found both the start and the end of the game, reset. Now we had to do some stuff. We're going to end up renaming some of the variables and stuff. But this is a loopback buffer of 8 bytes, and the purpose of this is when we read forward, we can't, or I shouldn't say we can't, currently we're not checking to see if we're at the end of the game until we find a carriage return, or sorry, a new line, not a carriage return. So we're going to keep going until we find a new line. Or we hit the end of the file. And in the event that we hit the new line character, we could very well be at the, very start of a brand new buffer, which would mean all the characters that we want to inspect to see if we found the end of the game were in the buffer previous to where we were. So every time we're done every time we process 256, is that my buffer size? 256 kilobytes. Every 256 kilobytes, so 256,000 bytes. It's more than that because it's 1024, but we'll say roughly 250,000 kilobytes. Every time we process the 250,000 kilobyte, hey Turskwill, we're going to do this buffer shift stuff. Scroll up. It's up. So this buffer stuff here, every time we process 250,000 kilobytes, we're going to back buffer 8 bytes. So a very, very small portion of the overall... Oh, that's not what I wanted to do. We are... Let me see. 0.0... Or no. Hold on, almost. 0.0032% of the buffer is actually kept in the holdover. Because we only really have to go back a couple bytes, but I kept needing to go back a little bit more. So I just screw it. 8's a nice number. It works. So we'll go with 8. So basically what we do here is we say, if I've got 8 bytes in my current buffer, because there's also, I had to test all this. This is why I did it offline, because it was very nitty gritty, not so much. It wasn't figuring things out. It was just testing. But there are many times where you may not have 8 bytes in the buffer. You may only have 7. And when that's the case, you have to take the last byte. So if I had, let's say 5. If I had 5 bytes in the buffer, well, right now I'm trying to say I want to keep, the last 8 bytes. So if I only had 5, I would have to go get the other 3 from the current loopback buffer. So what I do here is, this is probably the most inefficient part of the code. Because what that does, hold on, we're going to come over here. What that does is, so, oh shoot. Let's say I've got, we'll make these 8 chunks here. Oh, boop. I'll draw this out here. 4, 5, 6, 7, okay, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So the way I've done this is that I wanted the buffers to match in the direction that they were going. So as I'm reading from the real buffer, I'm taking from the end of that and adding it to the end of this. So when you're going backwards in one array, you're going backwards in the other array. So I've got this. This is going to be my loop back buffer. And then down here, this is going to be my actual buffer. So let's say I've got these guys in my current buffer. And now I have to figure out what I'm going to do here. So I've only got these 4, which means I need 4 more, right? So what actually happens is I'm going to move all this over and let's see, let's call this the garbage can. The garbage can doesn't really exist, but the garbage can is just values that we just don't care about anymore. We don't do anything with. So the way that the loop works here, the reason this is so inefficient is because the way that it works is it says, okay, I'm going to go through this for as many times as I have bytes in the buffer. Okay. And then I'm going to, how did I do that? Right. So in this one here, we're going to shift everything to the left by 1 byte for as many times as I have bytes in the buffer. So I've got these 4 bytes in the buffer. I have to make 4 spots. So it goes like this. It moves that one over. Everything moves over by 1, 2, and this shifts over. And this comes over here. And then the last one comes over here. We shift that one over. That one goes here. Then these all end up shifted here. And then we go, I'm going to add these to the end now. And now what I've got is the last 8 bytes of memory. So that's kind of roughly how that logic works. But that's really slow. It's really slow for me to say, move everything over 1, move everything over 1, I might be better off doing an array copy here of some kind. I don't really know, but it's fast enough. We're going to go over the numbers for now. It's fast enough for me right now. I would like to clean that up because it is kind of wasteful. It is kind of stupid. We are going for efficiency. We are trying to do it nice, but I think this is fine for us to move forward and, you know, continue on with other functionality that's important. I'm going to have to come back through and comment this because I coded some of this in a sleep deprived rage. We've also got this concept of backbytes. So again, I know I've named things poorly. I was tired. So we've got the concept of a buffer, which is the current 256 kilobytes that we're processing and looking for things. We've got the concept of an 8-byte loopback buffer. And now we've got the concept of the back 2 bytes buffer. So when you're trying to determine what the end of a game is, okay, the end of a chess game, let me bring up the documentation here in the PGN spec. So when we're talking about the end of a chess game in a PGN, let me scroll down here. There is a, in the move text, there's a termination marker, and it's always 1-0, 0-1, 1.5, 1.5, or star. Always. Always, 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 always. I'm open to be, you know what? I'll say it now. I could be wrong in the future when we start considering annotations and comments left in chess PGNs. But in terms of just notating a game, there is never a world where -0, -1, /2, or star will appear right before a new line or the end of the file. So the reason the back 2 bytes exists is we're processing, let's say left or right, we're reading left or right, we get to the new line here. I now have to go back 2 bytes to say, is the byte that's 1 back, is it a 0, a 1, a 2, or a star? If it's a star, we've found the end of the game. Okay, that's easy enough. If it's not a star, go back 1 more. If that character is a dash, and the one that we just looked at was a 1 or a 0, that's the end of the game. If it was a 2 and this is a slash, that's the end of the game. Okay? So that's what we're looking at right now. That's this 2 bytes back. Now the reason we need this is because, again, this is why the loop back buffer exists, is because if we're on index 0, so let's go through the different cases here. If we're on index 0, I'm going to comment all this stuff out later, because if I try to explain it right now, I'm also still tired because I didn't sleep last night, which had nothing to do with this, but so I will comment this out and explain it maybe next stream. But there's a lot of stuff here where I have to, like in certain cases, subtract by 1, and it usually has to do with what I've found, because we also have to contend with the fact that not every file is going to handle new lines and carriage returns the same way. So just know that all of these -1s or 0s, like when we get to here, we're talking about a line feed pad that could be 1 or 0. Well, if we subtract 0 from something, we're effectively doing nothing. The reason all that exists is because in some operating systems, when you hit enter, it's a 2 byte combination of /r/n, which is /carriage return /line feed. And we're looking for the line feed. So when we're looping backwards, if we want to find the end of the game, we have to skip over the /r when it exists, but not all the time. So that's what's happening with all the -1s that kind of may or may not be there. But I'm going to describe that a bit more in depth in the comments of this code as we get going. But so if we're on index 0 of the buffer, that means I can't go back anymore in the buffer. So I have to go look in my loopback buffer. And if I'm at a case of 1, well, then that means I've got 1 byte that I could potentially go back. So it depends. If I found a return, then yeah, I have to go. If buffer 0 is a return, then I have to go into my loopback. Because, so I'm on a new line. Oh, geez. No, I'm on a return. I've already lost my spot. This is why you shouldn't do stuff when you're tired. Unless I did this one backwards. If the end of file is found. Oh, right. And buffer at index 0 is a return. Then we go to the loop back. So that makes sense. So if I found the new line, the thing before it was a return, then I have to go back into the buffer because I've exhausted both of my only 2 buffer spots. But if the index is 1 and none of these are true, then that means I can take 1 from the buffer and I can take 1 from the loop back. And then in all other cases, I have enough room to do it just with, I believe just with the buffer. No, not. There's one case here. So if the buffer index -3 is less than 0, then we have another edge case where where that darn return runs us out of space again. Sorry, I'm just dying. Coughing up a storm. Hold on. My phone has made a mistake and it's telling me the temperature and freedom units, which we don't use in the rest of the world. It's not that hot out, but I am sweating. Oh. And I'm tired. Okay. But I want to get some of this done, so let's keep going. So all that said, we have now... It helps me to go over this stuff, so I'm happy to do it. We're now going to test all three of them. So the first one here is our... the first one we've got is our previous byte version. The second version is the one that uses strings instead of bytes. And then we've got the new one. Now, what I'd like to start doing today is, I don't know how much I trust any one of these yet. So I want to make a unit test where hopefully they all return the same result on a few different tests, and then we can make sure that all of these are working the same. So when we're trying to measure which one's faster, if the end result of what they come up with is different, we can't really say one's faster than the other because they don't give the same results, which they really should. So if we take a quick peek though at where we're at right now, I know this is just a throwaway main just so we can do some stuff, but let's see how many seconds they take, right? So I've got this set to run forever, and it's processing. So the 250,000 games in a go. Let's see how long it takes in seconds, and then we'll let we'll go through 4 or 5 cycles, and we'll let the JVM kind of warm up a bit. But let's see. Start that up. So 1.1 second, 1.9 second, 0.4. So way faster. Way faster. Way faster. Way faster. Way faster. Way faster. So this is whether it's right or it's wrong, whatever I believe it's right, but it's significantly faster than the other two that we've done so far, right? And hold on, let me bring up the test here. We've got another one. Let's bring up the profiler. Let's take a look at what does this look like. Oh, we can't look at that. Hold on. The reason we can't look at that is because we're running all three. Hold on. We don't want to do that because the string one is going to screw up all the garbage collection stuff, and these are all going to make it look pretty bad. So let's just we're just going to run this one here, and we're going to comment out the sysout for now because we don't need to see it. We know it's consistently, under a second, so it's like 0.2. So now we're going to run it again just so we can look at this. Reload. Yeah, see, look at that. Look at that. Look at that memory usage. Look at that. That's much better. Oh, we also have to make the objects now too. But that's so much better. Look at that. That's like 30 kilobytes. Okay? That's great. I mean, it is growing. That's a bit concerning. But I don't know. Maybe it's not. Does it ever slow down, and why does it keep going up? What happens if I do a manual garbage collection call? I don't like that this is continually ramping. That's bad. There is no reason for that. And we may have to figure that out. But let's let it run for a minute. Let's see if it keeps going up. I'm going to be concerned if we get to 200 meg. Because that's bigger than the file. So let's see what happens here. This is going to take a little while. But so we're at 119. And keep in mind, this is still processing all of this in 0.2 seconds. Okay, I think this is probably just going to keep going. Maybe. Yeah, okay. So let's see what happens if we do a manual. Okay, so something is leaking. You see that? Something is leaking. Okay, so that is something we will have. But still, even after all that, we are still less. We are still less than we were with the strings and stuff. Like, hold on. Oh, is it? I wonder if it was this. I doubt it, but like, let's try again. Let's see what happens if we comment that out. I guess we are also making a bunch. Okay, hold on. What about this? Is that significantly better? Please hold. Let's see if this gets up as high as the other one did, or if this stays low. Now that we're not doing that anymore. Okay. We're gonna let that run again for another minute. I guess while that's running, let's jump over and look at some of this other stuff here. I'm not like super familiar with this, so this is something else I'm learning. It's kind of like how to fully interpret some of this visual VM stuff. So like, let's just kind of poke around for a bit. So self time. That's good. We're spending like no time reading, which is also really good. Most of the time is spent determining the game, which is also really good, I think. Right, so this byte array... Is it? Oh. Oh. Wait. How do I... No, stop. Oh, can we not? Oh, we can't flush? Okay. Is there anything else I got to do here? Let me just... Oh, okay. Maybe it's because we're not closing these. Let me just try that real quick. I'm going to go back to Profiler. Okay. Let's see if that changes our position at all. Okay, okay. Hold on, guy. You want to be a bot? You want to be a bot? I got a thing for you then.
Fuck you.
Goodbye, Twitch bot. It was nice knowing you. See, it doesn't really seem that concerning because I'm only using 43 kilobytes of RAM, but I'm reading 256 kilobytes at a time, so it doesn't really seem that crazy. But I don't like that it continually grows. Okay. we'll come back and I'll have to do some research and figure out what kind of things are causing this to happen. I don't know. No, I never get those bots in YouTube ever. Maybe it's because I don't have a member button, so there's no... So like what they always say is they usually say something like, click here to buy views and follows and subs. But yeah, no, I don't get those on YouTube ever. So, let's see. Actually, you know what? We'll keep this one test a thing. And what we're going to do is we now have to set these up to all return things. So let's set this one up to... Okay, so we... Game indices. Now we have to... Oh yeah, we got to re-import this. And game bound. These are going to be longs. It's been a while since we touched this, so we are gonna do that. Come into here, and when we find a game, we are going to say, okay, game indices dot add new game bound start index end index. And then we are going to return that. There we go. And this is going to be a list of game bound. Now we also have to do that in here. We're going to game bounds. Game bound. Okay. We don't need to do this anymore, so this can come out. This can come out. Does this one even... Does this one even find the end of the game? It doesn't. Well, where do we reset things? Okay, so this one, I don't think we're really going to be able to compare, because this, what about this one? Does this one know when a game is over? Okay, so we might have to actually handwrite a unit test instead of comparing this one to that one, which is fine. But I don't think this is... No. Okay, so these ones, I can't write a unit test against these. So we're going to... I don't have this in a Git repo yet because I was just kind of messing around and I didn't know how far I'd get. So we're just going to move these out into a junk folder for now, and we'll clean it up and we'll make a Git repo later. Game importer, import games. Game bound. Okay, so let's make a test. And for this test, we are going to say, so basically what we're going to have to do is we're going to make a test file. We're going to manually determine the start and end byte. And then we are going to run this test to automatically tell us if, when this returns the thing, if that matches our handmade scenario. This unit test is going to run every build, so if we ever screw up the PGN importer, this is going to tell us. We'll write better unit tests later, but for now, this is what we got. So we are going to go back to test a thing. Okay. Oh, shoot. Go back. Import. P dot. Import PNG. And we're going to get that path. Main. Okay, so we're going to start with this one. Okay. What don't you like? An exception must be caught or declared. Okay, for now we're just going to throw. Go. There we go. And we're going to say P. Or no, we're going to say list of game bound equals that. Import list. And then now we're going to say that we want to okay. Assert assert equals 1, and then we're going to say GB dot size assert equals 0, and then we're going to say GB dot at index, or no, what is it? Get at index 0 dot get start of game assert dot equals, I believe this should be 796. We'll double check here. So if we assume this is 0, then we have to subtract 1 off the end of this, so 796 should be the end. And this is going to be gb.get 0.get end of game. And this should be fine. And it did run fine. We can see right here. Too older is okay. So now I want to make a new file, which we're going to call 2 games. And it's going to have this game, and we're going to come into the Berliner, because that's who we're already using. And we're just going to scroll down and find another random game. This one looks short. Let's pick this one. We're going to copy that. We're going to bring this over into 2 games, and then we're going to say this. And we're going to say this character is where. So one thing I wanted to check is when I go down, does this... It does. Okay, so that... Okay, good. So this character here is in position 801 because it should be 0 indexed, I think. So we're going to come back to our test. If I can figure out where I put it. Test the thing. It's going to be 801. Oops. Not that. And then we will... Here, one sec. Test. PGN pre-reads. This is going to be test with one game. We're going to do this, and we're just going to make another one down here for test 2 games. Actually, we can do it. We're going to start using the VI stuff here. So we're going to do 9 yank, paste, bam. Except it didn't grab the curly brackets. So like I'm still not good at this. Test with, oops, that's the wrong button. Test with 2 games. And this file is called 2 games. So this one is the same. We want to make sure that that still works. And then except this is now 2. And then, oh, we don't need to run this assert again. So we can get rid of that. And then in here, we now say the next one is going to be at 801. And this is going to be index 1 of this. And let's figure out where the end of this game is going to be. This should be at 1277. So we go. And the other thing we're going to do too is we're just going to add a few carriage returns onto the end just to make sure that it actually finds that properly. And we're going to come back to this and we're going to run the whole class and make sure it all works. It does. So it works with 2 games, which means it should work with 3 or more. There's really nothing in the logic that would insinuate that it's not going to work in other circumstances. So we got a nice little test case here. That's going to keep us on track as we go. Perfect. So that's good for now. So if we come back to here, this now works. We now have a list of games that we can actually use. So now we kind of have to start thinking about actually parsing the game. I have not quite decided how I'm going to do the parsing of the game yet. It sounds easy on its face, but strings suck. But I don't really know how I'm going to parse out all the other things. Like if we, oh wow, I haven't been showing the code for a little bit. So you guys haven't been watching these test cases that I ran. That's okay though. If we come back over to here, this is what I was making. I was making a test class. So we've got a game with 1 PGN, and this is how it should work. There should be 1 game in there. The game starts at this index, ends at this index. This game here has 2 games in it, so this should be this, and then we should be able to find the... We can actually do this a little bit nicer. We can do... we can comment these out while we're here. Actually, we can say... check for correct number of games. Check start index is correct. Check end index is correct. Check that. Okay, and then here we just do game 1, game 2. So we could do this bigger and fancier. Like we could give it the 250,000 and we could have it loop through and figure it all out. But that seems excessive for now. So this proves the point. So we're good to move on. So I don't want this now. Portable game notation. Okay. So this shouldn't be a PGN importer, perhaps. How am I going to? Oh, maybe this could be okay. We'll see. So, okay. How do I want to line this up? This is already really big, and I don't want to put any more code in here. Let's not worry about this at all. Let's just do this. Start of a tag pair. Oh shoot, there's a scenario that we haven't considered. There are times where you won't get one of these. And if game start is not found, the current byte is open tag, do that. But we also have to consider, we don't, okay, so this is important enough to go back for. This isn't required, technically. Per spec, it's not required. So in the event that I'm parsing, I also have to check for the existence of new... Ugh. I guess we're going to look for... Because this isn't a factor, so we're going to look for a period and go back, I guess. So let's say if game start is not found in the current byte is open tag. We'll say, because this code should not really run that much. We're looking for the first game. Looking for the first byte of the game. So I don't think it's going to be expensive to do this, but we'll see. If current... Oh god, we got to rename current byte. I don't know how long it's been, I mean the whole time, but I haven't realized so far that that had an underscore in it. That's gross. So let's put that up here. We'll go private static final byte turn okay. So if I find that then game start index equals total bytes read -2, because we have to go back one from where the period is. Okay, and then now we're gonna rename this while we're here. We're gonna say current byte And does this change what we've already done? Right, it's running forever. So let's, where's our test a thing? Test a thing. Still works. Okay. So now, in our 2 game, or no, let's make a. Okay, so we got game. I don't know how long we're going to want to keep using files for these, but we're going to keep doing it for now. I think I'm going to have to make it for the... Oh, crap. I'm dying again. Okay. So. For now, we'll keep using files, but we're going to rename them. This is game with tags. 2 games with tags. And we're going to copy this, and this is going to be games no tag. And we're just going to do this. Which should start at position 0 and end at position 597. And then 2 game with tags is going to also have one called 2 game no tags. Okay, and then same thing here. We're going to do this. And we'll figure out those bounds here in a second. We'll leave some carriage returns on the end here. And then we're going to make one more of these. So no tags first. We're going to do this. This is very important when you're unit testing. You want to make sure that you actually unit test a whole bunch of different things and not just the same test case over and over again. But okay, so now we've got that. So now let's go jigger up our test cases here. Hook them all up. So test 1 game with tags. Test 2 games with tags. Again, I will learn these VI key bindings at some point, but right now, without tags. It's going to be 2 with... Oh, that was spelled wrong. Without tags. With tags. Okay. So now we've got game with tags. 2 games with tags. Okay, 2 games with tags. And this is going to be game. No tags. 2 games. No tags. So let's see if just these work. Oh, right, we didn't... Okay, so that's not... Okay, hold on. Expected 0 but found 2? That doesn't sound right. Hold on. Oh, the actual's supposed to come first. Okay. Hold on. We gotta fix all of these. 1 0 796. Two games with tag. Oh. Okay, so I messed that one up. But it looks like it's gonna be broken here. So we rename this one to this for a second, and then with tags, and this will be no tags. Okay. There we go. So two, 0, 796 and 801 1277. 1. Come on, there we go. 1277. Okay. Interesting that this worked somehow. Okay, so game no tags. So we should have, this should fail. So let me see. Game no tags should start on 0 and end on 597. Which is test 1 game with 597. Go back here. It is going to start at 0, which is great. And it should only have 1. And then 2 games without tags. We come here, it's going to be 2 games. First one's going to start. Okay, so 2 games, no tags. It's going to start at 0 and end on 597, just like the first one. And 0 and pretty soon I am going to have to leave. That doesn't mean I'll be gone forever, but I'm going to be gone for a bit at least. And then this one is going to be 602. And then 885. Oh, that should be... There we go. Okay. Try that again. How's it going? It's going good. It's going good. I don't... Okay, there we go. I'm not really understanding what I did to break this. This one worked like a couple seconds ago, and I didn't change that file, and I didn't change that test. So This should be what? 2 games with tags, right? Yeah, 2 games with tags. Game with tags. 2 games with tags. Let's see. It's 2. That shouldn't really make a difference. So I don't... We could debug through it and see what's happening here, but that's really strange. This should definitely be detecting 2 games. Oh, believe me, I know. Believe me, I know. I'm usually good at remembering what I did. How I contributed to it. 2 games with tags. So yeah, let's, we can debug this test. Or I just won't set, oh, it works, okay. I did nothing, great. I also never really used, so let's run test. I've also never really used VS Code for any of this before. Okay, this is what I expected. I expected this one to maybe be dead in the next one. Because this is the stuff that we just added. So, and we also made like no code changes to really to really address any of it. So let's put a breakpoint in here and see if we ever get to here. And what happens if we do. So, yeah, we're going to test this guy. That didn't... Oh, okay. There we go. Okay, so where are we now? So where's current byte? You're not going to tell me over here, and you usually tell me in there. So let's see, current byte. Where are... Current byte is 49. Hold on, I need my ASCII table. God, why don't I have that bookmarked? Or UTF-8 table, rather. UTF-8 encoding table. I've only got like 15 more minutes, and then I got to take a phone call. So that is a capital letter I. Okay. So we are in this file. Hold on. Test 1 game without tags. Okay, we are in this file. Wait, what? There is no capital I in this file. What? That can't be right then. Is that a decimal or a oh, that's a hex 49. That's not a decimal 49. I need a different table. This is why I should have there we go. Here we go. 49 is the digit 1. Okay, that's what we want. That's what we want. Okay. So, if we go to our code again, so that's fine. We're just going to wait for it to come back. Now it's a 46, which is a full stop. So this is what we're looking for. And then what is total bytes read is 2. Good. So now we're going to back that up to 0 for the start of game index. That's good. And then this should be... We'll move this over a little bit. Good. Wait. Oh! I'm dumb. That's why. Hold on. All we have to do is set the... We forgot to add this line too, guys. That's all it is. Okay. Let's try that again. Run test. Okay, that one. Okay. That makes me feel better. That makes me feel better. We're just tired. There we go. All the tests work. Okay. So now we have effectively handled the edge case that I thought was going to be a lot harder to solve. I shouldn't celebrate yet, though. Now we have to add in the two the two that are going to suck the worst. I know I'm right-click copy pasting like a scrub, but I just turned on Vim motions and I haven't learned them yet. And every time I push Control, it does something, and I don't like it. But I'm gonna learn these Vim motions. I swear. Okay, test with 2 games. First with test with 2 games. First without tags. And then okay. Paste. Test with 2 games. Last without. You did something bad in D&D. That's not good. What'd you do? You gave a curse to a nice old librarian. Well, if there's one thing the group that I play in loves to do, it's pretend to be a librarian. Yeah, I'd love to know the curse that you may have gave one of my one of my friends. We pretend to be librarians in games all the time. Okay, so we may have to shut down the stream in a little bit. Any non-mag... Oh god, a potato. That really sucks. Every non-magical book. That could suck. 2 games. No tags. No tags. So 2 games. No tags first. Yeah, because I'm expecting a phone call in the next like 10 minutes. So if I get that phone call, I will have to abort for a little bit. 2 games, no tags, last, end. No tags, end. Okay, so now we gotta find... Okay, so this is... Just gonna grab this as well. I'm just gonna shove that here. Paste. Let's go find out where those are. So no tags first. We've got what, 0 and 597. That's already set up. And then game 2 starts on 602. Okay, so far fair game. And ends at 1078. Okay, and the next one starts at 0 and it goes to 796. Which starts the next game at 801. And ends at 1084. Okay. Let's see if we got this. Okay, that's actually all the edge cases I can think of for this. I think this is actually good enough now to move on. So, what have we gone through here? So, we'll do a recap with the last 10 minutes because there's no way we're really making any progress in 10 minutes on the next part. So maybe we'll kind of go over what we're working on so that if people are interested, they can pop back in. We might be, I think I'll probably be on again later. What I've been doing right now is just kind of programming. Anytime I'm doing this, I just kind of hit go live and we just kind of learn together. I've got a lot to learn about what I need to do here, so why not share it while I'm learning it? We've gone over this a bunch already. eventually I'll make a video for it so that I can just point to it. But we're making something that can parse chess games really quickly so that I can store them to a database and do something else with them. The cases that we have here is we've got these tag pairs may or may not exist. So that's what we were just kind of going through, is I got it working with the tag pairs assumed to always exist. And now we have a world where they don't have to exist, and if they don't exist, it's okay. We'll just take this as the start of the file instead. So that's fine. So our first, we've got with the tags, we've got without the tags, we've got 2 games in a row with the tags, we've got 2 games in a row without the tags, we've got 2 games where the first one doesn't have it and the second one does, and we've got one where the first game has it and the second one doesn't. So that covers all the different cases I had in mind. And when we come back later, what we're going to do is we now have this done. So the pre-read, we'll make this all green. So we find the index, we find the result. So all this stuff is done. Maybe we should make another page here and just say, we'll say game importer and then reread to find start and end of each game. And then this is where we're going to have the parser manager. No, not a. We'll call it a parser manager for now. Parser. So basically, what this is going to be, the parser manager is the thing that's going to take these start and end indexes. So where we're at with this right now is we want to multi-thread this. So this thing is going to take in this, if we go back to PGN importer, what this ends up making is a list of game bound, and game bound is just a start and an end indice. That's it. So the PGN importer really right now, I'm going to have to rename it probably, but the idea here is that this, is passed on to something else, and it's going to loop through the list, and it's going to say, okay, if I want to do this on 4 cores, go start the first core, or the first 4, or threads, not cores. Start the first 4 threads, and wait. When one of them's come back, give them another game. When the second one comes back, give it another game. And then just keep feeding them one at a time until they've all finished what they're doing. So I don't know. I've got a lot of RAM, so I'm going to try to screw around with doing most of this in RAM until I've got it, because I don't want to be doing read writes all over the place on my SSD. So I might buy a cheap HDD or another cheap SSD that I can just like rip through and don't care if it dies. But so yeah, we got this explained. We went through it again. This can now be deleted. Come on. There we go. No, why aren't you in insert mode? Like, for real? There. Okay. I'm just looking for anything else that's commented out to clean up here. Because next I'm going to have to go through and actually, like, make comments. Okay. This should be safe. I'm gonna also do some research into like how big of a buffer should I be reading. Like right now we're only reading in 256 kilobytes. But let's see, if I run this, oh crap, hold on. We need to change the main here. We still got 5 minutes. We'll uncomment that, uncomment that, uncomment that. So it runs pretty quick, right? 0.4 seconds, 0.2 seconds, pretty quick. Oh, shoot. What happens if I make this 512? Does it like speed up? Not really. So like 256 is a pretty good number. And let's see, does 128 slow it down? This will be the last thing we do before I end, but a little bit, not a lot. So 256 kind of seems to be the sweet spot. I kind of nailed that first try. We can research a little bit why. I just Googled what's a good, like, what's a good chunk to pull when you're working with data, and I guess 256 was probably the first thing I saw, and I said that sounds like a good number to start with. Because originally we were just doing 100 bytes at a time, because we were working with one game in a small file. Yeah, this was pretty good. We got some test cases written. We're moving really slow. That's okay, but I'll probably be back later today. We'll say, I don't know when, but it just kind of depends on life, right? I've got a bunch of kids. I've got a life. I got stuff I got to do. But I will be back next time I open this up to keep looking at it. That's why we pick away at these things one piece at a time. But I'm happy that this part's done, and now we can move on to looking into how we're going to multi-thread this. Yeah, you guys have a good rest of your day. Make sure to hit that follow button on Twitch and that subscribe button on YouTube. And you'll know when we come back. We play D&D a lot on this channel. We play a bunch of games on this channel. Lots of different stuff happening. So hopefully later today there'll be more programming. On Wednesday there will be some D&D. There'll be maybe some other streams in between. I share this channel with another guy we call Cal. He also does some streams from time to time. So we'll see you guys around.